So far we've looked at two of the ways to solve a system of equations. The first one was by graphing, and we noticed with some systems that graphing is not always the most efficient way to solve. And so then we looked at the substitution method, which is an algebraic method of solving a system, and it works out much better in those ones where graphing isn't efficient. So maybe our solution point involves some decimals or fractions, and a substitution method helps us with that. We're going to look at another method in this video called the elimination method, and this method in some situations works better than substitution based on the setup. And when we get to one that is definitely much better to use elimination than substitution, I'll point that out. This first example we're going to look at just to kind of get an idea of the basics of elimination. Now this one here is certainly one that would work out great for substitution because we do have this x here that we could easily isolate without having to deal with any fractions. But this one here is a perfect setup for elimination. Now let's think about what elimination means. Elimination, or to eliminate, means to get rid of something. And so what we're going to do in this first step here is we are going to eliminate one of our variables. When you look at the setup of these two equations, you'll notice they are both set up in the same order. We've got the x terms, the y terms, the equal sign, and then the constant. We also notice when we look at them and compare the x's, we've got one is a positive x, this is a negative x. Well, what's going to happen is we are going to eliminate the x's by adding these two equations together. Because what is x plus negative x? Well, 0. So they eliminate, they cancel each other out. And so that's the whole idea behind the elimination, that we are able to add our two equations together and eliminate or get rid of or cancel one of the variables. So when we do that here, x plus negative x, they cancel. We no longer have x's. 5y plus negative 2y is 3y. And 28 plus a negative 13 is 15. Well, we very easily got down to something. We can now divide both sides by 3, and we have that y is equal to 5. And now we just like in substitution, once we have one variable, now we need to substitute it or plug it back into one of the other equations. It doesn't matter which one. I'll go ahead and use this. Let's see, I'll use the second one. It's got a little bit smaller numbers there. Now I'll use the first one. So then I don't have to end up dividing by negative. So I've got x plus 5 times 5 equals 28. So x plus 25 equals 28. Subtract 25 from both sides, so x equals 3. And so our solution is 3, 5. Remember, we always want to check. So we'll go ahead and use our calculator to plug this in. We'll have 3 plus 5 times 5 does equal 28. And then we have negative 3 minus 2 times 5 should equal negative 13, which it does. And so this then is our solution. Now let's look at another one. We've got 7x minus 7x minus 1/3 y equals negative 29, and 2x minus 1/3 y equals negative 9. So the first thing we need to check is to make sure that things line up. We've got an x over an x, a y over a y, equals over equal, constant over constant. And so we're set up correctly. Now we need to look at what would cancel if we were to add these two together. And we notice that, so when we look at what could possibly cancel here, we notice that we've got a 1/3 y and a 1/3 y, but they are both negative. And so what do we need to do so that they can cancel? Well, they need to be opposite signs. Well, how do we make that happen? Well, we can change one of these to a negative if we change all of the signs for all the terms in that one equation. So I'm going to take this first one and I'm going to change all of my signs. So instead of a positive 7x, I'm going to make that a negative, make this a positive, make this a positive. I just multiplied essentially by a negative 1 to distribute through all of those terms. And so now I can add these two equations together, and I get a negative 5x. My 1/3 x and negative, or 1/3 y and negative 1/3 y cancel, and that is going to be then equal to a positive 20. Now I can divide by negative 5 on both sides and get that x is equal to negative 4. Now I want to substitute this negative 4 back in for x. I can use either one of my original equations. I'm going to choose the second one because it's got some smaller numbers, and so that's going to be a little easier to work with. So I've got 2 times negative 4 minus 1/3 y equals negative 9. 2 times negative 4 is negative 8 minus 1/3 y equals negative 9. Add 8 to both sides, so negative 1/3 y equals negative 1, and then divide both sides by negative 1/3, which is a positive 3, because remember you're actually multiplying by the reciprocal. So our solution then is negative 4 comma 3, and then let's substitute that back in. And remember we changed all the signs here, so this one was really 7 times negative 4 minus 1/3 times 3. Actually, I should put that in parentheses. And that should equal negative 29, which it does. And then 2 times negative 4 minus 1/3 times 3, and should equal negative 9, which it does. And so our solution is negative 4, 3. Okay, let's take a look at another one. Here we have x plus 3y equals 1, and negative 5x plus 4y equals negative 24. So the first thing we check again is make sure everything is lined up. We've got x over x, y over y, equal over equal, constant over constant. Now, how do we go about eliminating something? I've got a 1x and a negative 5x. I've got a 3y and a 4y. Well, these are unlike those last two that we did, where one of our variables had the same coefficient, and this one we don't. So in this one, we're going to need to, just like in that last example, we had to change the signs on the 1. In this one, we're going to need to do something to make the numbers be the same. And I'm looking at the x's. I see a 1x and a negative 5x. They're opposite signs, which we need, but they need to have the same number. So how can I make them have the same number? Well, if I make this x a 5x, then it'll cancel with a negative 5x. So what I need to do is take this equation and multiply everything by 5. So it now becomes 5x plus 15y equals 5. I just multiplied x, 3y, and 1 all by 5. Now I'm going to recopy this one so it's underneath. Negative 5x plus 4y equals negative 24. And now when I add these together, my 5x's cancel, and I'm left with 19y is equal to 5 plus negative 24 is negative 19. Divide both sides by 19, and y equals negative 1. Now I can go back to one of my original equations and substitute negative 1 in for y. I'm going to choose this first one. So I've got x plus 3 times negative 1 should be equal to 1. So x minus 3 equals 1. Add 3 to both sides, and x is equal to 4. So that says my solution is 4, negative 1. Let's double check it. So we've got 4 plus 3 times negative 1 equals 1. And then we have negative 5 times 4 plus 4 times negative 1. And that equals negative 24. So we are good with 4, negative 1 as our solution. Okay, let's look at a fourth example. We've got 2x plus 7y is equal to 2, and we've got 5x minus 2y is equal to 83. So again, first thing we check is everything lined up, which they are. Remember, if they don't line up, you're going to need to rearrange them so that they do first. So everything lines up. Now let's look at see what can cancel. Well, here I've got a 2x and a 5x. They're not the same number and they are the same sign. We need same number, different sign. And here we've got a 7y and a negative 2y. Well, they're different signs, but they're not the same number. And so this is going to be similar to that last one in that we're going to have to change something to make one number equal another. Well, we've got a little bit different issue here. We can't multiply 2 by anything to make it 5. We can't multiply 5 by anything to make it 2. I can't multiply 7 by anything to make it 2, and I can't multiply 2 by anything to make it 7. And so this is a case where I'm actually going to need to multiply both of my equations by something. And so we've got a couple of different options. You could make the x's, multiply both equations to make the x's cancel, or to make the y's cancel. I'm going to go with the y's because they're already opposite signs. And so I'm going to, what can I multiply 7 and 2 by to make them equal the same number? So I'm looking for the least common multiple of 7 and 2, which is 14. So if I multiply this first equation by 2 and the second equation by 7, let's see what happens. 2x times 2 is 4x plus 14y is equal to 4. And then 5x times 7 is 35x minus 14y is equal to, and 83 times 7 is 581. Now I've got a 14y and a negative 14y because I multiplied both equations. Now we can go ahead and add these together. So we get 39x, our y's cancel, equals 581 plus 4 is 585. Divide both sides by 39. So x equals 585 divided by 39 is 15. And now I'm going to definitely use the first one. It's got smaller numbers to plug into. So I've got 2 times 15 plus 7y equals 2. So 30 plus 7y equals 2. Subtract 30 from both sides, so I have 7y equals negative 28. Divide both sides by 7, and y equals negative 28 divided by 7 is negative 4. So I have 15 comma negative 4 as my answer. And let's double check that with our originals. 2 times 15 plus 7 times negative 4 should equal 2, which it does. And 5 times 15 minus 2 times negative 4 should equal 83, and it does. And so that then is our correct answer. Okay, let's take a look at a word problem. We've got two families that go to a hockey game. One family purchases 2 adult tickets and 4 youth tickets for $28. Another family purchases 4 adult tickets and 5 youth tickets for $45.50. We want to find the cost of 1 adult ticket and then find the cost of 1 youth ticket. So the first thing we have to do here is set up our equations. We've got 2 equations that we need to set up, and we know we're always looking for the 2 sets of data or the 2 sets of information that go together. Well, it tells us right here we're talking about 2 families, and so let's see if we can make equations 1 for each family. Well, what do we know about the first family? We know they've got 2 adults and 4 youth, and they spent $28. And then the second family has, 4 adults and 5 youth, and they spent $45.50. Well, what are we trying to find? We're trying to find the cost of 1 adult ticket and the cost of 1 youth ticket. Well, how do we get the totals? If you bought 2 adult tickets, you take 2 times the price of an adult ticket. That's what we're trying to find. And you take 4 times the cost of a youth ticket, and you add those 2 totals together to get the $28. Same thing here on this one. So our equations then would be 2a plus 4y equals 28, and 4a plus 5y is equal to 4550. So there's our system, and now we need to solve that, and we can solve that with our elimination method. We've got everything lined up appropriately, but we don't have anything that would cancel right off the bat. So let's look at our A's and look at our Y's and see what's going to be the easiest to make cancel. Well, if we look at the 4 and the 5 Y's, in order to get these to be the same number, we're going to have to multiply both equations, which is fine, that would work, but we want to do this the easiest way possible. If I look at my A's, I only have to multiply one equation because I can multiply 2a by something to make it cancel with a 4a. Now remember, we want them to be the same number, so we want to turn a 2 into a 4, so we want to multiply by 2, but we want them to be different signs. And so I'm actually going to multiply this equation by a -2 because I want it to be a -4a, not a positive 4a. So I'm just going to rewrite my new equation underneath. So -2 times 2a is -4a minus 8y is equal to, and -2 times 28 is -56. And so now this became that equation right there. Now I'm ready to add them together. My a's cancel. I end up with -3y is equal to, and 4550 minus 56, or plus -56, is a -1050. And then divide both sides by -3, and we get y equals 3.5, which means a youth ticket costs $3.50. Well, we also want to know what an adult ticket costs, and so we are going to substitute this $3.50 back into one of these equations. I'll go ahead and use the second one, or the first one here. We've got 2a plus 4 times 3.5 is equal to 28. 2a equals 4 times 3.5 is 14. That should be a plus, not an equals. Equals 28. Subtract the 14 from both sides, so 2a equals 14. Divide by 2, so a equals 7, which means an adult ticket would be $7. And let's go ahead and plug that back in, or substitute that back in just to make sure. So we have 2 times 7 plus 4 times 350 should equal $28. It does. And 4 times 7 plus 5 times 350 should equal $45.50, and it does. And so there are our ticket costs. $7 for adult and $3.50 for a youth or child's ticket.